Hi everyone, let's solve this problem maximum subarray. Let's read the problem statement. The problem statement says we are given an integer array nums. We need to find the contiguous subarray which contains at least one number and it has the largest sum. Okay, so the answer whatever we are going to return should have at least one number. This is very important. We need to return at least one number, right? So for example, if we have all the negative numbers, we need to return the max out of those rather than returning 0 or not, right? So before going on to the solution, I just want you to remind that this is a problem that we are tracking from a Blind-75 list. So these are like multiple solutions. I have put all of them here and I'll put the link of this sheet in the description below. Before seeing the visualization, let's see the quote of the day. So it's from this book called Alchemist, right? So it says the possibility of having a dream come true, it makes life interesting. I mean, whenever you're working, you have to live in the right moment, right? The current present moment, and having a belief that whatever you think may one day turn out to be true, right? That makes life interesting. So okay, let's go to the visualizations. Okay, so the first idea that comes to our mind is what I can do is I'll take all possible subarrays. So let me draw some array here, right? So let's say what I can do is, let's see from this place. I say okay, maybe my answer start from this position, right? If it starts from this, what are the possible end position for this position, right? It could be here itself at this element, or at the next element, or at -3, or at 4, or at -1. Like I can keep going for all the elements, right? So for each start position I can have n end positions, right? Like basically n minus no, actually n position, right? For because this will also be an end position, right? So for each element I can have n position, and for this guy I will have n minus 1 position. Like this is one subarray and this is second, this will be third, right? So what I can do is for each possible start, for each possible end position, I will calculate the sum of that subarray in order n time, and I can get my solution in order n cube, right? So which is for each subarray of size order n, right? Like basically for each start comma end time, which is order n square, I can take the sum in order n time, and that will be my answer. For example, if I was looking here to here, this will be my subarray, right? I can take the sum from here to here in order n time and I'll get the answer. We can slightly optimize it by saying that I will consider all possible subarrays, right? All possible start and end position, but I can sum them in order 1. How? Like for example, let's say if I was considering this subarray, right? So let's say this is my array and I'm considering this subarray. I had already, let's say, solved from this position to this position. So whenever I was expanding from this position to next position, right, I already knew the sum of this subarray, right? I to j minus 1. So I can calculate it, just add this number, right? So this is like, okay, I can optimize this solution to order n square. So these are like two techniques. The next one, okay, let's go order wise. There's another option which is divide and conquer. Okay, so in divide and conquer, what I say is I will ask my left. So let me draw it here. Let me first clean it up. Just 1 second. Eraser. Do we have eraser here? Yes. Let's clean this. We don't need this now. Okay, and we don't need this as well. Okay, so now in divide and conquer, what we say is we will pick the half. We will do the input split into half. Let's say, okay, this was my array, right? I might have a half split. Let's say, okay, the total number of elements are 6 now. I say, okay, find the answer from this side. Okay, let's call it L max. Okay, I'll find the answer from this side, like the right side of the array, which will be R max, right? These are like two separate individual components. This is one, and second is I will start the maximum suffix sum going from mid to left side and max prefix sum from here, right? Let's call it M sum, and my answer will be max of all these, which is max of L, M and R. We'll see how do we do it. We'll use recursion here, and this solution is order n log n. Why? Because each time I will be splitting, so my recurrence that comes is my n size array. Okay, it is the split I do is of size n by 2, two splits of n by 2, and it takes me order n times to compute prefix plus suffix sum, so I get order n log n. But now let's see if we can optimize it more, right? How can we do it? So in order to do that, what we can do is we can follow a technique. Let's name it later, it's already like known algorithm. What I can say is, how about okay, each index has candidate, so let's call it this technique at each index at as candidate. Okay, so this will be as candidate. So what I mean by this is, let's say if I have a particular array, like for example, let's say consider this, right? I say okay, at this I'll consider each possible position as the end of my answer, like which is like end of the subarray I'm interested in. For example, I'm here, I can say okay, maybe at this point this is the end, right? If this is the end, tell me the answer, right? This is what I'm trying to say. I say okay, if this is the end, whatever is the answer so far and from me, and if this was the end of the subarray, I'll pick the max answer out of those, right? And for the next iteration, when I'll be considering this guy, I need to keep track of the suffix sum, which is because when this guy will be the answer, it needs the max answer from this part, right? So all I'm trying to say, so this algorithm comes under the name called as Kadane algorithm. So Kadane algorithm, right? It doesn't even read like Kadane, right? So in Kadane algorithm, what we say is, whenever I have a new index that is coming to me, I can consider it as, let's say, end. You can go from right to left and say the start of the answer as well. You can say okay, whenever this particular element is the end of subarray, what is my answer already available, and if I make the answer more, if it is the best option, if it is okay, keep it. But still, for the next iteration, I will keep track of maximum suffix. There are different variants on how to implement this Kadane algorithm. We'll explore it in today's video, and this video will be going to be longer because of those explanation. But the overall idea, I think you got it. The idea is we will consider every possible index as the answer's end position, and then populate the answer, keep populating the answer, and for the moment next answer come, we will keep some information available to us, so that calculation of that answer becomes easy. So let's do one dry run also. Let's see if I can erase this. Okay, yeah, so let's erase this as well. So what I say is yeah, let's see here. It's okay, so at 5, right, at 5, what is my answer? My answer will be 5 only, right, which is the start. And at 4, my answer will be 5 plus 4, 9, right? So I'll keep track of 9 as suffix as answer. A total answer is 9 and my suffix answer is 9. And now at this position, I say okay, what is my answer? If it ends here, it is 8 actually, but my actual answer, the max answer, is still 9, right? So let me write max is 9, and so far my answer is 8, right? So whenever I add this guy, it will become 15, and 15 plus 8 in the next iteration, it will become 23, right? So the overall sum is what I'm getting as an answer. If it's not clear yet, let's see the code, and I think things will get clear from there. We'll solve all these. Let me write all these. So okay, I'll not go through the order n cube solution, which is order n cube we will not solve. It's very like basic brute force. But let's solve order n square. I think we will get time limit exceeded in that case. Also, what I say is okay, my answer is minus infinity, because I need to consider one element at least, right? So what I can say is I can't consider it 0 because there might be some negative element, and if I'm returning 0 as an answer, because that will be maximum, right? So I'll keep it as minus infinity. I say okay, for I in range of length of nums, for j in range of, now I have to start from I itself, right? Because I need to consider that as a start and end, right? So my sum so far is 0. Let's call it sum of subarray is 0, and now I can add this guy, right? Sum of subarray plus is equals to nums of j. So I have calculated the sum whenever I was going from left to right in this direction, like now, for example, in the previous iteration I might have calculated till this point. If I'm considering this guy, I just will add the overall sum with this element, right? So I'm getting this answer, and I'll keep tracking the answer. What is the maximum answer so far? So okay, so what I do is okay, so my answer now is max of answer, and which is okay, this has to come here, right? and subarray. For each subarray I am calculating it. So this loop is order n, this loop is order n, and I'm summing up in order 1 itself, so it's order n square solution, right? And I will return answer. Let's see. I'm pretty sure it will give us time limit exceeded. Okay, so this was order n square brute force. Now let me copy this. Okay, time limit exceeded. Let's solve it using order n log n now. I believe that will also give us time limit exceeded error itself. So let's get rid of this. Okay, so this part is done, and now let's see how can we solve it with brute force. We'll use recursion there. I can say, okay, I will give you nums. This is the start and this is the end, right? And that will return me the max answer. So I have nums, I have left, and I have right. If left is equals to right, okay, I'll return that because that will be my max answer, right? So that is the answer, correct? And otherwise I'll take the middle element, left plus right minus left mod 2, as I explained in the visualization. I'll get the max answer from Lmax, which is helper of nums from left to mid, and Rmax, which is helper from mid plus 1 to right. I got these answers. Now I need to get L suffix answer, which is from left. I need to pick the suffix answer. From right I need to pick the prefix answer and sum them up and get the M answer, and finally I return the answer of this. Return max of Lmax, Rmax, and Mmax, right? Okay, and my Mmax is left suffix plus right prefix, right? But now we need to see how do we calculate left suffix and right prefix. Okay, so my left suffix is, let's say for now it's minus infinity. Okay, and I need to start from mid to left, right? So I say, okay, for I in range of left to mid in reverse order, right? Reversed order, I need to start, and my mid element should also come, right? That is fine. So from left to mid I'll pick. I say okay, and let's have suffix is 0 so far, and my suffix plus equals nums of I. So now I'm calculating the left suffix, which will be max of left suffix and suffix, right? This is my left to right traversal, like from to compute the suffix. Again I'll do it for prefix. This is my left prefix, right prefix, and I will say prefix I have, and here I have to traverse from mid plus 1 to right, so this is where I have to go. So I say okay, prefix plus is equals to nums of I, and my right prefix will be right prefix. I add it with my prefix, right? So this is my right prefix, and I got all these answers. So let's see if it works. I'm not sure whether it will be submitted or not, because it might give us time limit exceeded. Oh god, okay, it's accepted. Cool. Okay, so this was the order n log n, and now let's see how can we go for order n solution, right? So let's comment it out, let's take it down. So the next solution is our Kadane's solution, right? So for that, first I can do is I say okay, let's see if the maximum possible answer itself is a negative, right? So let me say okay, if mx is itself less than 0, right, what should I return? I should return that element, because otherwise summing them up will keep making me negative, right? Otherwise I can keep my answer 0 because something will come now, right? There is something positive there, so I can keep answer 0, right? And my answer here, which is like, okay, whenever it's ending at a particular position, right, is 0, and I say, okay, for num in nums, answer here plus is equals to num, and if answer here, and what I can do is answer here should be max of 0 comma answer, because something is, because I don't care about the answer when it becomes a negative. This can definitely not be answer because something is positive inside here, right? So the moment my suffix, my answer at this particular index, let me re-explain it here. So what I'm trying to say is, if at particular index, let's say this was array, right? If this at this index I calculated everything, I summed up everything, right, in this section, right? If everything overall sum becomes negative, then I don't even consider it as an answer. I say, okay, this was itself a 0, because for next guy it will become easier to sum only him, right? He doesn't need to consider negatives, right? Because this idea is very important to understand, guys. The idea is the moment this guy itself could be negative or positive, but if something negative is coming to him from here, why should he consider it, right? So whenever I am giving the opportunity for next answer to calculate in an order 1, I will pass him 0, right? I will pass him 0, that way, because everything was negative, why do you want to keep it, right? So this was the first idea. Okay, so in that case, whenever, and my answer can always be more than 0, right? Because I have already checked it. So what I can do now is, my answer is max of answer comma ans here. So if it was negative at a particular index, I don't need to consider it. So I return answer. Let's see if it works. Okay, let's submit it. Awesome, it does. So now if you see, okay, let's see this. If I don't use this condition, right, let's see what happened. See, I had -1 and 0, and I had to return -1 as an answer, right? This case failed, right? And now how do we fix it? Either we put float of -infinity here, right? Let's see if it works. Okay, again now we are getting negative as an answer, like 0 as an answer. Why? Because every time I'm considering it with 0, right? Whenever like the suffix sum was becoming negative, I had made it 0 itself, and that's why it's not working. So this way, this initialization, there's a lot of things are going, which is like, this is Kadane variant 1, right? So let me write it as here as def Kadane 1, and it took numbers, okay, and this was the condition it was asking for, and then it was working, right? And what I can do is return self dot Kadane 1 of nums. Okay, let's rerun it again. Okay, awesome, it works. So guys, I'll teach another variant, like which makes it very easy to understand, and that is Kadane variant 2. Let's call Kadane variant 2, and the idea is very simple. I say, okay, Kadane 2, and it's very easy. The moment because we always need something as an answer, right? I don't need to do all these condition check and all everything, right? So what I can say is, okay, my answer is -infinity, which means every time I will get some answer that will be replacing -infinity for sure, right? So what I say is, okay, for num in nums, and I have suffix sum, which is 0 for now, but this suffix sum will always keep one element with him itself all the time, right? So what it means is, okay, suffix sum is max of suffix sum plus num or only num. Now I'll come to this, what it exactly means. So the moment I got the suffix sum, only then I'll get the answer. So my answer will be answer and suffix sum, okay, and I return answer. Let's see if it works, and then I'll explain you what's the intuition behind this way of coding things up. Okay, awesome, it does. So guys, let's see what exactly is going on in this second version. Okay, so in this second version, what exactly is happening here is, when I take these elements, right? Okay, this is my array. If let's say I was considering this element as end, right? I'll say this has to be there in the suffix sum, no matter what. If these guys were bringing negative with them, I won't consider them, but I will make the decision here itself. Either the answer will be this, or whatever is coming from the left plus me, So every time whenever I'm changing the answer, I have one element in my answer all the time. So that zero kind of issues will not come. I'll start from left to right. Every time at this point suffix sum, this element must be there. At this time, this element must be there. This time, this element must be there. So on and so forth. Every time, some element will be there in the answer, right? So I'll do the max. So these were like two variants. Just meditate on them. You'll get to know what exactly I'm trying to say here. So there are like multiple solutions we have seen. We have seen order n cube, order n square, and order n log n solution, which was divide, conquer, and then finally we saw order n. The reason all these solutions are important is because there are some kind of brute forces which are optimized with these optimized solutions. So whenever you see a new problem, this kind of same issues come up there, you can start thinking about, okay, how did we be optimized in these standard problems, right? So I hope guys you like the solution, and remember, dreams do come true. So keep working hard, keep pushing yourself. Someday you might get a chance, we might get a chance to live our dream life. See you guys in next video. Thank you for watching.